Today we're going to introduce methods into the programming. Remember, object-oriented programming, again, objects are created or classes are created with attributes and methods. We've talked about attributes a fair amount. Now let's talk about methods. A little more complicated to do the declaration and the definition for methods, but once you do a couple, it's all repetitive. Okay, so how do you define and call methods in the same object? How do you call them from other objects, which is the real value here? Distinguishing between attributes and local variables. When do we create a method and how does it look in Java? So, when we declared a variable, all we needed to do was say its data type and its name. When we declared an attribute, we would say that it's private and then data type and name. Methods are again a little bit more complicated, and the reason is, remember when we talked about algorithms, we had to have an input and an output. We had to have describe what goes in and what gets returned. So that means we have public or private, the visibility portion, public or private, followed by sometimes the keyword static, but quite frankly the only method you should have ever is the main method, so that's almost always going to not be there. And then the data type of the returned value. If nothing is returned, we use the expression void. And then the name followed by a list of inputs. So that's a little more complicated. Then once we do that declaration, then we get the actual components. So let's go back to Hello World with the public static void main. At the time I said, I'm not going to explain that, we'll explain it later. Well, now is the time. Public static void main, what does that mean? Public, everybody can see it and use it. Static, basically means it always exists, it never changes. Main is the only method you should have that is static. Void, it does not return a value. It doesn't give you anything back. Main, that's the name. And then inside the parentheses, you put in the kinds of things that you need for input to the method. And main just has a standard input. We can't change it. It's string args, string with the square brackets. That really means it's an array of strings. And then inside the curly brackets is the body of the method. And as you know, all it does is it prints out hello world. That's the whole body. In the other example we used with the stapler, it looks a little simpler, right? Public void staple. Oh, okay. Public, everybody can use it. Void, it does not return a value. Staple, notice I don't have anything in between the parentheses, so it does not require any input. And all it does is it reduces the number of staples by 1. So that's the body of the method. We'll do a lot of examples of methods today, today and tomorrow. That's the main point of the 2 days. Now, why do you have these methods? Well, usually methods are called by other objects. So, for example, we're going to work with random data. And on the right, I've got my random data class. And it's got some attribute, which is a list of integers, what I'm calling data, and then I have some methods. I initialize the data in one method. I do, that's right here, public void initialize data. Tell me how much data you want, right? How many integers do you want? Public void print data. It just spits it back out. Public int calculate maximum. Oh, so look what happens when I initialize the data. Public, everybody can use it. Void, it does not return a value. All it does, remember, it does what a method is supposed to do. It changes the attribute. It initializes the data by changing the attribute. The only attribute we have is data, which is a list of integers. And basically what we're doing is we're filling in randomly what the integer values are. And then print data, public void, public everybody can use it. Void, it does not return any values. Print data, all it does is it prints things out to the screen. But here we have public, everybody can use it in int, which means it returns a value, calculate the maximum, And we run through that little algorithm that we talked about to find the algorithm before, and it returns, sure enough, return max, returns the maximum value. Over here we have another another class, and the way this works is this class is actually going to call these methods. And we'll do examples of that in the camp today. This is where object-oriented programming is really powerful. Objects that interact with each other. And by the way, since I hopefully named my methods over in the random data class, gave them good names. Initialize data. What do you think that does? Well, it probably initializes the data. Print data. What do you think that does? Calculate maximum, right? I give these things descriptive names. And now over here, I can read and I can tell what's happening just by reading the code. Oh, I'm initializing the data. Now I'm printing the data. Now I'm going to print out, and what am I calculating? I'm calculating the maximum. So you can see what the code is doing, or at least attempting to do, just by reading through this. We'll do a number of examples of this today and tomorrow. Okay, now when do you make these methods? Let's see. You make the attributes to describe the object state. And then think about how, this is, by the way, not an easy thing. Think about how somebody's going to use the object that you're creating. Ask yourself, if I had this object, what might I want to do with it? What might I want to know about it? And then you're going to make methods for each of those things. Okay, I want it to do this. I need a method for that. I want it to do something else. I need a method for that. I might need to know something about it. For the stapler, I may be able to ask it, how many staples do you have left? I want a method for that. This can be difficult. And again, this is where, becoming a good programmer or a good software engineer, takes a long time. It takes a lot of practice. Determining what these methods should be and where they should go and how they should be carved up is a difficult thing to do in general. All right, so we'll do practice with this today, though. Fortunately, today it's pretty cut and dried because we're doing examples.